Hi everyone, this is our Edpuzzle on electric fields in solenoids. So, we already know the basic rules of attraction and repulsion in magnets. Opposite poles attract while same poles repel. And most of you have probably seen the basic magnetic field of a bar magnet, which describes the magnetic force around a magnet which goes from the north to south pole. However, the magnetic field lines are actually based on how a north pole will react around the magnet and is made up of all the combined vectors showing what direction the north pole will go. So next, the strength of the magnetic force depends on the distance away from the magnet. In these diagrams, we can tell where the magnetic force is the strongest based on the density of the field lines. So, in this first diagram, which object would feel the strongest magnetic force? We can tell that object A would feel the strongest force because it is in the spot where the field lines are the most dense. Okay, so in this second picture, which object would feel the least amount of force? Again, we can tell that it would be A because A is in the spot where the field lines are further apart from each other. You may be wondering how this relates to our project. Well, first we have to start with electromagnets and their magnetic fields. As you guys already know, Hans Christian Ørsted discovered that the electric current in a wire creates a magnetic field, the first connection between electricity and magnetism. If we take a closer look at the magnetic field around the wire, we can see that the field lines are perpendicular to the wire. This takes us to the curl rule, stating that if you take your right hand and point it in the direction of the flowing current, the direction of the magnetic field is in the direction in which the fingers of your right hand would curl if you wrap them around the wire. But what would happen if instead of having the wire being a straight line, you wrapped it in a circle? The magnetic field of the wire wrapped in a single loop starts to look similar to the magnetic field of the bar magnet that we saw earlier. However, what would happen if we added more loops to the wire? The magnetic field becomes stronger and closely resembles that of a bar magnet. This looped wire creates a shape called a solenoid. The magnetic field on the inside of the solenoid is stronger than the magnetic field on the outside, and we can see that with the density of the magnetic field lines being much greater on the inside than on the outside of the coils. As we now know, adding more loops to a coiled wire creates an increasingly stronger magnetic field, and closely stacking multiple loops to create a solenoid concentrates the field even more. The benefit of using a solenoid over permanent magnets is that they can generate as stronger magnetic fields by adding more coils instead of trying to stack permanent magnets, which would be heavier and wouldn't be able to combine all of their magnetic fields as well.